So first two examples of trig, so cast your minds back to high school and see if you can remember how to do these. So what we've been asked to do is to find the missing sides. We've got the length of two sides and we want the other side, and they are right angled triangles. So what Pythagoras said, if we just do a quick sketch, apologies for the lines not being straight, but what Pythagoras said is if you've got a triangle like this, and if it's got a right angle in it, don't be using this stuff if it doesn't. So that's a right angle there, it's 90 degrees. So if you were to draw a triangle like that, if you were to draw a square on this side, and another square, 1, 2, 3, 4, 5, another square on this side, and figure out what the area of those were, then those areas would add up to the area of a square on the long side, which is called the hypotenuse. So that's what Pythagoras is. It's quite a cool result when you think about it. And you can do some interesting cutting up pieces of paper that you might have done in high school to show that that's true. So when we're doing a Pythagoras, or when we're doing a trigonometry problem, so trigonometry, the study of triangles, first thing to do is draw the sketch. So just to save a bit of time, I'll just grab the sketch I've already drawn. Just move it a bit closer. Okay, first thing to do is to double check you've got a right angle. And so we've got a right angle here. Often the question will tell you that it's a right angle. Next thing you do is you label your sides. Now usually the way we write Pythagoras, so the area of the squares on two sides add up to the area of the square on the hypotenuse. We usually write that as c squared equals a squared plus b squared. Now what's a and what's b doesn't matter, but what c does. So you need to make sure you're finding the longest side. The longest side, the hypotenuse, is always opposite the right angle. So c is going to be that side there. The other two sides doesn't really matter. I'll call this one a, I'll call this one b. So the first thing you do is label your sides so you know what you're working with. So we're trying to find out what c is, and we've been given a and b. Write down the formula. C squared equals a squared plus b squared. In our case, c squared, let me just write a bit bigger. So c squared is equal to 15 squared is a plus 20 is b, so 20 squared. We want to find c, not c squared. So you can just do the same thing to both sides. Opposite of squaring something is to take the square root. So we'll take the square root of that, we'll get c. And we'll have to take the square root of the whole of this side. 15 squared plus 20 squared. Not sure why I'm writing all this in green. Okay, put that in the calculator or your calc pad or whatever you're using. So we are trying to find, let me just shimmy this across a little bit if I can, maybe I can't. So we want to find the square root of 15 squared plus 20 squared. It's 25, so this one is one of those special ones where it works out to be an exact number. It's 25, now it's 25 meters. So missing side is 25 meters long. And you could probably just check your answer. If you've drawn a scale diagram of that, roughly to scale, you can check your answer is roughly correct as well. Just to save time, I'm not going to do that here. So that's the first one. So in this case, what we wanted to find was the hypotenuse. For this next problem, so for problem B, they've given us the hypotenuse. That's the right angle up there. Opposite is here. So they've given us the hypotenuse. We want to calculate the other side. So let's quickly do that. I'll drag down the sketch I've already drawn to save a bit of time here. Should be okay. So same process. Find the right angle. So that's the right angle there. Look for the opposite. That's going to be your hypotenuse, which you usually call C. Other two sides don't matter. So we can call this one B, call this one A. It really doesn't matter. Write down the equation. So C squared equals A squared plus B squared, Pythagoras law. Put in what we know. So we know that 41 squared, because that's what C is, 41 squared is equal to a squared, that's what we're trying to find out, plus 35 squared. Okay, what's next? We're trying to get a on its own. Let's put a across here first. So we'll just swap sides. A squared plus 35 squared. Now you don't have to write all these lines. I'm just writing it out to make it clear to anyone who's not sure. Okay, so I want to get rid of this 35 squared. So it's plus 35 squared at the moment. So what I'm going to need to do is I'm going to need to take away 35 squared from both sides. So that 35 squared take away 35 squared is going to be 0, so that's going to disappear. So we're going to end up with a squared equals 41 squared, take away 35 squared. I don't want a squared, I want a. So a is equal to square root of all of the other side, 41 squared minus 35 squared. Let's stick that in the calc pad. So this time we're doing square root 41 squared, take away 35 squared. It's 21.35. We'll round that to three significant figures, so we'll do 21.4. When it's exactly in the middle, I usually round to the even number. Different people do different things. So that's going to be 21.4. Look back to the diagram. What were our units? Units were millimeters, so this must be in millimeter. And write out the answer. So missing side. Is 21.4 millimeters long. Okay, so for Pythagoras, first thing is you're checking it is actually a right angle triangle. Can't use it otherwise. Then you're looking for your hypotenuse opposite the right angle. So you're labeling that C, other two A and B. Write out your formula, substitute in the values. You might have to rearrange the formula to get your answer if you're not finding the hypotenuse, and then get your answer around to the right number of significant figures and you're done.